ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Yeah, students, let us continue here what we are discussing, light absorption. So here centermost one is called chlorophyll A and it's nothing but reaction center. What you find here, reaction center. This is the place where reaction takes place. So this is very important. Now this is being surrounded by hundreds of pigments. So this all hundreds of pigments together they are called as accessory pigments. They are called as what? These are all called as accessory pigments. What do we call them? They are called as accessory pigments. What are accessory pigments? Chlorophyll B, C, D and E, carotenes and xanthophylls. Now, as the light is falling onto this, as sunlight is falling onto this, so here light is falling on the place and falling where absorption and falling of light is taking place. That place is called as antenna. The place where absorption of light takes place is called antenna. Now here the total system itself is called a photosystem. Itself is called photosystem because all absorbing the light, they all are absorbing the light, and the total complex is called a light harvesting complex. It's called as a light harvesting complex. It is called light harvesting complex. So when you take the light harvesting complex, now listen carefully. There may be there are two types of photosystems. There are types of photosystems. How many types? There are two types of photosystems. How many types we have? Two types of photosystems. I think this is visible now, sir. Right. What are the two types here? Photosystem 1 and photosystem 2. So here, if this absorbs the wavelength of light 700 nanometers, then this is called as, this itself is called as photosystem 1. This itself is called as photosystem 1. What is the meaning of this? The absorption of light with what is falling onto this. The absorption of light what is falling onto this. If this chlorophyll A, the center chlorophyll A, if it absorbs 700 nanometers wavelength of light, then this total photosystem is called photosystem 1. So this light harvesting complex itself I am calling it as what? Photosystem 1, or itself is called as P700 reaction center. Itself we call it as what? P700 reaction center. Okay. So what is the meaning of that? Here the meaning is photosystem 1 is called, it's based upon the absorption of light by chlorophyll A. How do you call this is 1 and 2? We have two types. We have one photosystem 1, other one is photosystem 2. Why do you call 1 and 2? It all depends upon the chlorophyll A. If chlorophyll A absorbs wavelength of light 700 nanometers, then it is called as what? Photosystem 1, or itself is called light harvesting complex number 1, or itself is called P700 reaction center. P means photosystem, PS is also photosystem, photosystem 1, or it absorbs. Why it is called? Because chlorophyll A absorbs 700 nanometers wavelength of light. Who absorbs 700 nanometers wavelength of light? Chlorophyll A. Chlorophyll A, where it is present? In the center. Center chlorophyll A is present. Surrounding accessory pigments are present. Accessory pigments, they protect the chlorophyll A from photooxidation. If the chlorophyll, centermost chlorophyll A, if it receives the light of 700 nanometers wavelength of light, then it is called photosystem 1. Okay, or itself is called light harvesting complex number 1. or itself is called PS1 or itself is called P700 reaction center. Now if you look at on the chloroplast, we may find so many here. So this is one photosystem, there may be one photosystem here. So there are so many photosystems. Okay, so here also photosystem is there. So if you take this is 1, let us take this is 2. Yeah, so in the chloroplast there are photosystems are present. This is 1. Then what is the difference with 1 and 2? Here if it is absorbs 700 nanometers wavelength of light, then this is called photosystem 1. Suppose just beside you find one more photosystem. Suppose if it absorbs 680 nanometers wavelength of light, then it is called photosystem 2. What is the difference? Absorption of light. If the absorption of light is 700 nanometers wavelength of light, it is called photosystem 1 or P700. Suppose on the chloroplast we have so many photosystems. On the thylakoid as well as we find some of the photosystems in the stroma also, right. So let us take this is 2 for example, or let us take this is stroma. Let us take this is present in stroma. Let us take this is present on thylakoid membrane. Where it is present? On thylakoid membrane. Imagine PS1 or P700 is present in the stroma part, P680. Here it absorbs 680 nanometers wavelength of light, it is called PS2. Imagine this is present on thylakoid membrane. Okay, why I am telling you all this? This is thylakoid membrane. Maybe this is present in the stroma. Let us take this is all nothing but stroma. That means I want to tell you the point very clearly that some of the photosystems exist on thylakoid membrane and some of the photosystems exist even on stroma. That means within the chloroplast you find photosystems exist. We classify them into 2 categories. The one which absorbs 700 nanometers wavelength of light is called PS1, and the photosystem which absorbs 680 nanometers wavelength of light by whom? By centermost chlorophyll A, then it is called P680 or PS2. So we have altogether how many types? We have 2 types. One is called PS1, other one is PS2. So what I have drawn here? PS1 because it absorbs 700 nanometers of wavelength of light. Now let us see, let us draw even PS2, that is photosystem 2. Now in the same chloroplast, here and there is a distribution of photosystems. Same I am drawing here. In the center you find chlorophyll A, and here it absorbs 680 nanometers of wavelength of light. So here 680 nanometers, surrounded by there are many pigments which are called accessory pigments. Okay, surrounding what you find? You find accessory pigments. What are accessory pigments? Chlorophyll B, C, D, E, carotene, xanthophylls. And these accessory pigments protect the chlorophyll A from photooxidation. Now light is falling. As light is falling here, what is that here? Here in this case, chlorophyll A absorbs 680 nanometers wavelength of light. Chlorophyll A absorbs 680 nanometers wavelength of light, then itself is called as photosystem 2 or itself is called as light harvesting complex number 2 or itself is called as P680 reaction center. This part I think it's visible, right? Yeah. Now let's go with this. Now when you take this, what is the difference here? Here in this case photosystem 1 is there. What absorbs is 700 nanometers wavelength of light. It all depends on whom? Center chlorophyll A, because here reaction takes place. If it absorbs 700 nanometers, it's called light harvesting complex number 1, PS1, P700. Why? Because the total complex is called light harvesting complex. It absorbs light, and in this the all chlorophyll A, B, C, D, all accessory pigments are there. Along with the chlorophyll A, the total system itself is called photosystem. Light harvesting complex itself is called photosystem. And here it all depends upon the chlorophyll A. According to the absorption of light, they are divided into two. So, this is complex number 1, light harvesting complex number 1, also called PS1, also called P700 reaction center. Now, coming to this, here light is falling on all are absorbing the light. Same thing, the place where light is absorbed is called antennae, and the light falls on all pigments here. As a result, what happens? But centermost chlorophyll absorbs only 680 nanometers wavelength of light. That's why it's called photosystem 2, or itself is called light harvesting complex number 2, or itself is called P680 reaction center. Okay, so what we have? P700 and P680. This is called photosystem 1, this is called photosystem 2. Here 700 nanometers wavelength of light is absorbed by chlorophyll A. Here 680 nanometers wavelength of light is absorbed by chlorophyll A. So, we have two systems, photosystem 1 and photosystem 2. Light harvesting complex number 1, light harvesting complex number 2. Right now, suppose in the microscope I gave you the chloroplast, maybe you all science students are observing where the reaction center is there and where photosystems are existing and all that. Then how to find the difference? If I give two photosystems, how do you come to know? Because chlorophyll, which wavelength of light it is observed, you cannot observe looking in the chloroplast, right? It all depends upon chlorophyll A. If it takes 700, we call 1. If it takes 680, we call 2. But how do you come to know whether it has taken 700 nanometers or it has taken 680 nanometers? So, there are clear differences to identify photosystem 1 and 2. That I will give you in the coming classes. Once if you complete non-cyclic and cyclic electron transport system, you will understand how electron transport system takes place. After you understand that, then I can give you differences between photosystem 1 and 2 very clearly in the coming classes. But at present, to identify few differences I can give you. Here if you look at, if you observe in reaction number 1, reaction center number 1, you can see more carotenes. Photosystem 1 contains, here it contains more carotenes. If more carotenes are there, this is photosystem 1. Suppose you find here more xanthophylls. Of course, A, B, C, D all are present. Along with that, we find more xanthophylls. If more xanthophylls are there, then we can understand that it may be photosystem 2. More xanthophylls. More carotenes are there, then we can identify that as light harvesting complex number 1 or PS1. That is, it contains more xanthophylls. In the photosystem, you can see more of carotenes. If more of xanthophylls are there, then of course B, C, D also there, carotenes are also there, but more number of xanthophylls. Carotenes are also present, but more number of xanthophylls. If more xanthophylls are there, then you can identify that as PS2. That we can take it as what? PS2. PS2 itself is called light harvesting complex number 2, or itself 680. It contains more xanthophylls, here it contains more carotenes. Of course, there are many differences are there. So, when you take the chlorophyll A by B ratio, so here if you take chlorophyll A by B ratio, here 4:1, here 1:1, and here if you take chlorophyll A to carotenoids ratio 25:1, here it will come 5:1. So, do not worry, I will give clear differences once we talk about electron transport system. At that time we can find, we can write a list of differences between a photosystem 1 and photosystem 2. So, I think you understood now what are photosystems, right? Now, So let us write now. Where are we in here? We are in the light reaction. We were in the discussion about a light reaction. So when you take the light reaction here, very importantly here, in this case if you look at what is happening inside here. So if you take, this is a chloroplast, okay. What we can find here? Thylakoids, and group of thylakoids is called what? Grana. Now where are the photosystems? Here are the photosystems, and some photosystems are there even in the stroma. Some photosystems are there in the stroma and some photosystems are there on the thylakoid. 1 and 2 we call, right. Then what else we study here? Now light is also falls on the thylakoid membrane and that causes what? Splitting of water. So when light falls into the granum or thylakoid, what is happening here? The splitting of water is taking place. H plus ions along with the production of what you can see is nothing but oxygen. Splitting of water takes place, along with that what are released? Protons are released, electrons are released and oxygen is also released here. So what is the second step in light reaction? First step we completed what? Absorption of light. What is the second step we write here? The second step is nothing but splitting of water. Splitting of water itself is called as what? Photolysis of water. Itself is called as photolysis of water. Where the photolysis of water is taking place, I already gave you and told you very clearly in lumen of thylakoids. In the lumen of thylakoids. So if you take in the lumen of thylakoids here, the two water molecules, for example, let us take two water molecules are undergoing splitting here. Thank you so much. So when two water molecules are undergoing splitting here with the sunlight, so when the sunlight is falling into the lumen of the thylakoid, then what happens? Why I have taken two molecules of water? Because to show you oxygen too, right? So all together here 4 protons are released, 4 electrons are released and there is a release of 1 molecule of oxygen. So here this is happening in the sunlight, that is why it is called photolysis. In the presence of light there is a lysis of water. Very, very important. So here to get the balance of O2, 2 molecules of oxygen we are needed. So we are taking the count for 2 molecules of water, so that we get 2 oxygen nascent molecules, together it is called 1 molecule of oxygen. So along with the oxygen, what are released here? Look at the count here. There is a release of 4 protons and 4 electrons. 4 protons, 4 electrons and along with that 1 molecule of oxygen. 1 molecule of oxygen. What is produced here is oxygen. That is why this is also called as OEC. Why it is also called as OEC? Oxygen evolving complex. The splitting of water, photolysis of water is also called as oxygen evolving, right? Yeah. So evolving, not evolution, evolving. So you can write oxygen evolving complex. It is giving out oxygen. So oxygen evolving complex. Whenever you get it in the question itself is speaking about photolysis of water. So oxygen evolving complex OEC itself is called as photolysis of water, right? Why? Because oxygen is released out. Oxygen evolving complex. I hope you will remember, right? Photolysis of water itself is called oxygen evolving complex. Then how there is a breaking of water here? Now breaking of water or splitting of water occurs with the help of which minerals? Now we completed mineral nutrition. Which minerals are involved in splitting of water? So the mineral elements required for splitting of water. What are they? Very importantly, calcium, manganese, Mn2+, including Cl-. Which mineral elements plays very important role in the splitting of water means this all you have to remember. What are they? Calcium, manganese and chlorine. So these minerals, they act as catalyst in the splitting of water. Very important. Calcium, manganese, chlorine act as catalyst in the splitting of water. Very essential. So here this count is very important because we have to make the count in the next step. In the next concept we have to write the count. At that time we will discuss very clearly electrons, how many will be passing, how many protons they carry. Count is very important. So for that you need to remember very well this reaction. You may be thinking what is there in that zone is splitting of water, protons and electrons, but here electron and proton count along with oxygen molecule release is very important. So I repeat this small part here. A splitting of water where it occurs is lumen of thylakoids. So that's why lumen of thylakoid itself is called as what? A proton reservoir. Why? Because here it releases all the protons. All the protons are released here. All protons are stored in, where they stored? They all will be stored in the lumen. As the lumen stores all the protons, so here lumen of thylakoid itself is called as proton reservoir. It stores all the protons. By storing protons, what it will do? These protons are used in, the protons which are stored here, the protons are used in ATP synthesis. The protons are used in ATP synthesis. Try to remember. Lumen, what it will do? Inside the lumen there is a splitting of water. Continuously protons, electrons, oxygen is released out. So what are accumulated here? Protons will accumulate. Where? In the lumen of thylakoid. What do you call the lumen? Lumen is called proton reservoir. Using these protons, what it will do? Protons are used in the synthesis of ATP. So from the protons there is a synthesis of ATP. So that part will come later. Right. So all of you got, I think, very simple concept here. This part is very simple one. Let us quickly revise. Splitting of water itself is called photolysis of water, itself is called OEC, oxygen evolving complex. It happens in lumen of thylakoid. It stores and accumulates protons. Using protons in later part of reaction there is a synthesis of ATP. So how water is splitting here? Now 2 water produces 4 protons, 4 electrons and 1 molecule of oxygen. Now which mineral elements are required for splitting of water? From mineral nutrition we are connecting in the point here. Calcium, manganese, chlorine are very important. They act as a catalyst and play a vital role in splitting of water and releasing protons, electrons and oxygen. Now let us continue further. So here let us discuss about, in light reaction, let us discuss about electron transport system. Electron transport system. What are the steps in light reaction we are discussing? First is absorption of light. With that we could be able to categorize photosystem 1 and photosystem 2. Second step is splitting of water. Splitting of water causes release of oxygen, right, the 2 and 3. Second step is photolysis of water, third step is release of oxygen. Fourth step, what is left in fourth step? Synthesis of ATP and NADPH. So, how synthesis of ATP and NADPH takes place? The synthesis of ATP and NADPH occurs with the mechanism called as occurs through with the mechanism called as electron transport system. Meaning, just I told you that, what did I told you just now? 2 water molecules is getting splitted, 4 protons and 4 electrons, along with that oxygen. Oxygen comes out. Now, what is very important things here? Passage of electrons. Electrons, they will keep going from where to where? PS2 they will enter. From PS2 they will enter into PS1. Meanwhile, they involved in synthesis of ATP, and after PS1 they involved in synthesis of NADPH. Don't worry, this is what we have to discuss in detail. So, 2 water molecule, when it get broken down, what are released? 4 protons, 4 electrons and oxygen. Oxygen is released out. What happens to electrons? Electrons, they keep getting transported from one photosystem to other photosystem. As electrons are keep moving here, electrons are keep moving here. This is called electron transport system. Okay, electrons keep moving from one photosystem to other photosystem. When they are moving here, each electron, one electron carries 2 protons. When it is moving, each electron, it will carry 2 protons. Electron will not leave the protons here. Electron will take the protons along with that. That means here it's 1 electron is there, it also carries 2 protons. Here also it carries 2 protons. 2 protons here. As a result, it keep moving from one photosystem to other photosystem. In generally, if you look at electrons will enter PS2, first it enters into PS2, not PS1. From PS2 to enters into PS1. While moving from PS2 to PS1, it generates ATP. Try to remember the steps. So, we have to discuss in detail with this process. Don't worry, we have to discuss in detail. But overflow, just overall flow, if you look at, electrons first enters into PS2, from there goes to PS1, and while going it synthesizes ATP, and from PS1 goes to next concept, next component, it is involved in synthesis of NADPH. That means synthesis of ATP and NADPH occurs through electron transport system. E means electron, T means transport system. This is called as electron transport system. Okay. So, what happens through electrons are getting transported, that is why it is called electron transport system. What happens with electron transport system? There is a synthesis of ATP and NADPH. How ATP and NADPH2 are synthesized in light reaction? Only by electron transport system. Now, we are in the discussion about electron transport system. Now, let us discuss electron transport system. Now, this electron transport system, what we find in light reaction, so that is why I am not erasing the heading, this also come under light reaction, because end products of light reaction are nothing but ATP and NADPH. So, electron transport systems, we have 2 types of electron transport system, it is of 2 types. Let us take the first one as non-cyclic electron transport system, ETS. And let us take the second one as a cyclic electron transport system. What are the 2 types we have to remember? Non-cyclic electron transport system and cyclic electron transport system. So, electron transport systems are of 2 types. right. So, when you take non-cyclic electron transport system, itself is also called as Z scheme. Itself is also called as what? Z scheme. Okay, it is called non-cyclic. It will not come back to its place. That's why it's called non-cyclic. Now, let us see general diagram I will give you. Later we will go with the in detail discussion about that. Initially, what I can see is PS2. PS2 itself is called as P680. PS2 reaction center itself is called as P680. What is falling onto this? The light is falling onto this. So, there is a absorption of sunlight. So, there is an absorption of light up to how much? 680 nanometers. That is why it is called PS2 or P680, or it is called light harvesting complex number 2. Now, so where this is happening? On the lumen of thylakoids, there on the surface of thylakoid membrane. PS2 is located on the thylakoid membrane, where it is present on the thylakoid membrane. Now, when light is falling and enters onto this, what is the chlorophyll A here? Who is the main reaction center? Chlorophyll A here. Along with that, what it causes? Splitting of water. Let us take two water molecules. Splitting is happening with the absorption of sunlight, and as a result 4 protons, 4 electrons and oxygen. Who are the catalysts needed here for splitting of water? What is happening here? Splitting of water. As a result, who is produced here? Oxygen is produced. So, that is why it is also called oxygen evolving complex. Splitting of water or oxygen evolving complex, where it takes place? Within the lumen of thylakoid. Where it occurs? Within the lumen of thylakoids. What are the catalysts it is needed? Calcium 2 plus, Mn 2 plus, Cl minus. They act as a catalyst. They needed for splitting of water. Right. Now, with the absorption of sunlight, the PS2 will get excited. So, it becomes P680 star I am keeping, or it is also called excited state of PS2. With the absorption of sunlight, it got excited state of PS2, right. Now, whatever the electrons which are produced here, one electron is carrying 2 protons. Electrons are moving with the PS2 state to PS2 excited state. Electrons are moving, right. Now, this is called as uphill reaction. This is called as what? Uphill reaction. Electrons are moving. It is called uphill reaction. Again from PS2 to electrons are coming to PS1 or P700. Okay. So, here while coming the electron, here also electrons are carrying the protons. So, each electron is carrying the protons here. When electron is moving from PS2 to PS1, there is a synthesis of ATP. So, here is a synthesis of ATP. ADP plus inorganic phosphorus combine to form, and there is a synthesis of ATP. Synthesis of ATP happens from where to where? When electrons are moving from PS2 to PS1. That is why this is called as a downhill reaction. This itself is called as what? A downhill reaction. What is happening when electrons are moving from PS2 to PS1? What is synthesized here? ATP is synthesized. Now, then again PS1 electrons are here with PS1. At the same time, sunlight is falling on PS1, right? With the absorption of light. PS1 transport system also, there is an absorption of light, because this is also photosystem. There is an absorption of light. With the absorption of light, PS1 will get excited state of PS1. So, remove that cyclic. We will discuss about cyclic later. We are in the discussion about what? Non-cyclic electron transport system. So, what is happening here? There is an absorption of light. Absorption of light is happening from where? Again from sunlight. So I am telling again clearly because again you will get a doubt from where it is getting light. Definitely from sunlight, because this is also a type of photosystem present in the chloroplast. So with the absorption of light, here there is an excited state of PS1, or itself is called P star 700. So with the absorption of light it will get excited, right. Now, so after this it is involved in conversion of NAD plus, it produces into NADPH2. So there is a synthesis of NADPH2. So better I can write down clearly. So here absorption of no doubt sunlight, let us take, and here it is involved in conversion of NAD plus into NADPH2, and this is, there is a synthesis of NADPH2, very important. Now again this is called uphill reaction, again this is called uphill reaction, and synthesis of NADPH2, it is called a downhill reaction. This is called a downhill reaction. What are getting synthesized here? ATP gets synthesized, and what are get synthesized? NADPH2. So what are the end products of light reaction? There is a synthesis of ATP plus NADPH2. So when you take the ATP and NADPH2 here, so we can take here ATP and NADPH2 synthesized from where? This is very important. This is called non-cyclic at Z scheme. Light absorbed PS2 get excited, goes to P680 excited state, and one electron carries 2 protons. When electron is moving from PS2 to PS1, there is a synthesis of ATP, downhill reaction. This is uphill reaction. From PS1 to excited state of PS1, uphill reaction. PS1 there is involved in NADPH2. This is called a downhill reaction.
ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన ఎన్ఎస్ఆర్ ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ ఎన్ఎస్ఆర్ ఇంపల్స్.